Hello students, thank you for being here. We're going to hit the highlights of lesson 3 from unit 2, all about congruent triangles. This is the first part about congruent triangles. Remember that this is just the highlights of the lesson. The best thing for you to learn more deeply is to attend class. All right, as we're discussing congruency, we need to know what that means. Congruent is our geometry word for equal. So when I say sides are congruent, that means that the sides have the same measurement. When I say angles are congruent, I mean that the angles have the same measurement as well. We're also going to use the congruent symbol in statements to indicate that. So you'll see that congruent symbol, it looks like a wave over top of an equal sign. We know that we have segments because we have the segment bar above 2 capital letters. We know that we've got angles because we have the angle symbol in front of one singular letter. Looking at our picture, we can see what the congruence looks like by the hashes on the sides or the little semicircles on the angles. So it'll be up to you to either look at a congruence statement to know which sides and angles are congruent to each other, or be able to look at the picture to do that. And then from there, be able to write your own congruence statement. So if I'm looking here at my figures, I can quickly and easily write congruence statements by putting a triangle in front. Why do I put the triangle in front? Because I know that we're talking about a triangle as my shape. I know that there's 3 letters when I name a triangle, and I can name the very first triangle in whatever order I want. We tend to do things alphabetical, so I'll call this triangle ABC. Now, the second name is the one that really matters because we need to make sure that the corresponding parts, remember the corresponding parts are the parts that match up with each other or the parts that are congruent, are in exactly the same position. So again, it's another triangle, and we need to make sure that whatever corresponds with angle A is in the front. So looking at the semicircle with 3 little hashes on it, that matches up with D. I'll put a D in the front. Looking at B, I've got 2 little hashes. That looks like an E goes next, and then we'll end up with an F, which matches up with your C. We would say here in our congruence statement, the triangle ABC is congruent to triangle DEF. Again, you can write it in whatever order you want. There would be nothing wrong with saying that triangle CBA is congruent to triangle FED. But if I said triangle BAC was congruent to triangle DEF, I would not be correct. Am I correct that those 2 triangles are congruent? Yes. Is the congruence statement indicating the correct corresponding parts that are congruent to each other? No. Therefore, that would be an invalid statement. Invalid meaning not accurate or not true. And that would be marked incorrect. Just the same as using lowercase letters instead of uppercase letters would be incorrect in these situations as well. Again, you can use your figures to help you write the figure congruent statement, or in this case, the triangle congruent statement, or you can use the congruent statements for your segments and your angles to write it whichever way you're given the information or whichever way it's easiest for you to look at it. That's what I would do. As always, we are layering our knowledge, which means we're taking information that we've already learned and applying it or connecting the dots between the 2. So we talked about transformations in the previous unit. Transformations mean that one shape is exactly the same as another shape. I've just changed it in some way, translated, rotated it, or reflected it. So when I'm looking at one shape that is congruent to another shape, what I can think or imagine is that the second shape is just a transformation of the first one. It's been turned, flipped, or slid to another position to be exactly the same shape, just in another location on your screen, on your paper, on your coordinate plane. And if I were to map the shapes together or put all of the corresponding parts on top of each other, it would look like one figure, showing that they are congruent to each other. Now, when writing your congruent statements, you would likely see that your figures are separate from each other using completely different letters to indicate the points or the vertices. You also may see that your figures are connected. Keep in mind, if the figures are connected, even though you don't clearly see 3 sides matching up with 3 sides, it is happening because this segment of DE is exactly the same as the segment of A prime, B prime, which means that that side is congruent to itself. And if we knew that the other two sides were congruent to each other, that's enough information to say that we have congruent figures here. All right, keep in mind that the more practice you do here, the better you're going to get at it, and the more opportunity you will have to see different figures and recognize congruence within those figures or within the congruence statements. Good luck on your IXL assignment.